Hi guys, welcome to science. Today we're going to be talking about air. And the first thing I want you to know about air is that it has weight. So go ahead and watch this clip as we show to prove that air has weight.
Hi, I'm Jared and welcome to Science Demonstrations for Young Learners. I have my hands full here because our big idea is quite interesting. The big idea is that air is matter and air has weight. Science tells us that air is matter and air has weight. So how do I show you that? Welcome to my scale. I have a neat balance here that almost is balanced. Hey, it's working pretty good. I have two balloons and I want to show you that air has weight, so I put air into them. So what I'm going to do is I'm going to remove the air from one of these balloons. We're going to go with this one right here. So if I take the air out of this balloon and this balloon still has air, it should be heavier. Let's see if we can get this to work. Okay, I've removed the air. It's slowly leaving the balloon. Whoa, it's swirling because I get a force pushing on my scale. I'm going to stabilize it just a little bit and watch the science happen. Wait a second. It's spinning. I'm going to stop the spinning. Oh, look! This is heavier. Why? There's air in it. There's no air in this. Air, no air. Air actually has weight. It's heavy. Science is cool. Thanks for watching.
Now you know a little bit more about air. And the reason why I wanted you to find out about air is that it has to do with air pressure. And air pressure is a big part of the weather. So watch this clip to find out what air pressure is.
Hi, I'm Jared. Welcome to Fun Science Demos. Today we have a little bit of a science puzzle for you, and it has to do with air. Here it is. I have a balloon inside this bottle, and that balloon is filled with water. How did I get the balloon into this bottle? I'll give you a hint. It has to do with air. So I know what you're thinking. Well, balloons filled with water are flexible. I can squish them. I can squeeze them. I probably just squeeze the balloon into the bottle. Let's see how that works. I have a balloon about the same size as the other one. Bottle, same size opening. I'm going to try and push it in. Getting somewhere here. That didn't work too well, did it? So we've cleaned up after our little water explosion. That clearly did not work. What happened is our balloon, I don't think you can see it, maybe a little bit, the balloon actually ripped as I was trying to push it into the bottle. That is not the answer we're looking for here. The answer to this puzzle involves air, and to get to this answer, we need to explore air. And our exploration begins with a balloon and a bottle. Let's take a closer look and see what we can find out. So we start with a balloon and a plastic bottle. Any plastic bottle will do as long as it doesn't have any holes in it besides the opening. And all I need to do is squish the balloon together and stuff it down into the bottle. And stretch the balloon's opening over the top of the opening to the bottle. I have it all set up. Now let's get ready to explore air. Well, where is the air? I have air all around me, pushing down on me, and I also have air inside this bottle. I can't see it because air is invisible. Now, air may be invisible, but through science we've discovered that air is matter and air takes up space. So air inside this bottle is matter and it takes up space. So what will happen if I try and blow this balloon up? It's not too difficult. I can blow up a balloon. I didn't really have any problems doing that. What will happen when I try and blow up this balloon and add more air to our bottle? What do you think? Let's find out. I'm not faking. I'm actually trying to blow air into this balloon and it's not working. Why? Because the air inside this bottle is taking up all that space. It doesn't let me blow that balloon up. So I know air inside this bottle takes up space, but now I want to use a different bottle and try it again. But there's one thing different about this bottle, and it's not the size or shape. There's something else that's different. We want to see if you can find out. So I'm going to take the balloon off of this bottle, same balloon, move the bottle off. Now I have a bigger container. I'm going to stuff the balloon into the bottle, and I'm going to stretch the balloon's opening over the opening of the bottle. There's one thing different about this bottle. Watch what happens when I try and blow this balloon up. Why was I able to blow this balloon up? Well, there's air inside the bottle. That air is taking up space. Why was I able to add more air to this bottle? What do you think? If you listen carefully, there's a clue. I'm going to do this 2 more times. Listen. It sounded like air was moving. Air actually was moving. Well, how is that air able to move? Well, if you look carefully down here, there's a hole in the bottle. I'll show you with this little stick. The stick actually can go through the hole. Well, what did that hole allow the air inside this bottle to do? It allowed the air, as I blew into the balloon, that balloon forced the air and pushed the air out of the bottle. Watch this. I have the empty plastic bottle. I line my hole up with a bottle. I'm going to blow in. The air rushed out of this bottle and moved that plastic bottle off the table. There was no air trapped inside the bottle. The air could escape out. So now let's explore air a little bit more. We're going to do the same thing but change one little thing. Same bottle, same balloon, hole in the bottle. I'm going to blow the balloon up, but put my finger over the hole and watch what happens. Once I put my finger over the hole, the balloon actually stays blown up. Look at the top. You can see there's an opening in the balloon, but the air isn't coming out. Watch this. I can drop my stick down. It's open, but the air is not coming out. Well, why is that happening? So what's really happening here is that I have my finger over the hole. What happened with that hole? Well, that hole allowed air to move in and out. When I put my finger over the hole, air can't rush back into the bottle and push the air in the balloon out into this room. What happens when I take my finger off of the hole? Air should be able to move in and push the air out of the balloon. Let's see science in action. It worked, and I could even hear the air moving. Another way to do this is to use this hole to take the air out of this bottle and let the air in this room blow that balloon up. I'm going to inhale lots of little times. It's going to look like I'm kissing the bottle. I'm not. I'm going like this. I'm taking all the air out of the bottle. Watch what happens to the balloon. Here we go. I had to take all the air out of that bottle, and the balloon looked like it was magically blowing up. It wasn't magic at all. It was air doing all the work. So we are close to figuring out the answer to our puzzle, thinking back to the water balloon in the bottle. Well, all I need to do is the same thing we just did, but add some water from this pitcher. Here we go. Find the hole. Now, what do you think the next step is? I have an open balloon. I have a pitcher of water. All I have to do is pour water from the pitcher into the balloon and then tie it off. Let's do this. You can hear the water running into the balloon. Okay, now at this point you want to be very careful, because what would happen if I take my finger off of the balloon? Air would rush into this bottle and force not just air out of this balloon, but also the water that's inside. So I'm going to stick my finger in, grab it, I'm safe to release, tie off my balloon, and now I have a balloon in a bottle. Why? Because air. Through science, we've discovered that air is matter and it takes up space. And we can do a lot of fun things with air. If you want to learn more about air, check out our links in the video description. Science is so cool. Sometimes it's a little bit wet. Thanks for watching.
You just found out what air pressure is, and meteorologists use air pressure to predict the weather. Watch this clip to find out how they measure air pressure.
Hi, I'm Jared. Welcome to our channel of fun science demonstrations. Have you ever been driving in a car going up a mountain or flying on a plane and the insides of your ears felt weird? It's almost like a popped inside. Well, what's going on with that? Well, that's the big idea today. Through science, we've discovered that there's lots of air surrounding our planet, held in place by gravity, and that air is pushing down on us from all directions, and that pushing down creates pressure. Scientists like to measure that pressure with an instrument or a tool called a barometer. And we are actually going to make our own barometer right now. We only need a few simple materials to make our barometer. It's super kid-friendly. A scissors, a balloon, some kind of firm, rigid container that'll hold up so that I can stretch the balloon over top. A flat toothpick works best, or a straw, or anything that I could attach to the top of the balloon, and a little bit of glue to hold my pointer there. Here's what everything's going to look like when we're finished. This jar here is my barometer. I have my balloon stretched over top. My little pointer is glued to the top, and that pointer is going to move up and down as the pressure changes. How do I mark those changes? Well, that's what this bottle's for. I'm going to put little marks as that pointer moves up and down so I can keep track of the air pressure. I don't really need blue water or any water in this bottle. I filled it with water so it could be a little more sturdy and heavier, and I use blue because blue's cool. So now let's make our own. What I'm going to do is I'm going to be cutting the bottom part of this balloon off, and I want to make sure I'm careful. You might want to have adult supervision, but a simple cut is all we need. Next, I'm going to stretch my balloon over top of my container and snap it into place. Now, when you do this, you might find that the balloon sort of loosens up. And that's okay. If you get a rubber band, stretch the rubber band around your container. What you can do is tug on the balloon and get everything nice and tight. Now I have a little membrane, or a piece of rubber, in this case latex balloon, that's going to measure my air pressure. You know what this actually is kind of like? It's kind of like the inside of my ears. I have this little film membrane inside my ears that actually responds to air pressure pushing down. Now, you can use pretty much anything for a pointer. I've seen lots of straws, and I've made them with straws and pins and all kinds of things. I found that the flat toothpick works really well for this design. So what I need to do is attach my flat toothpick to my balloon. I'm just going to use a small little dab of glue. Now, that's a big dab of glue, so how do I fix that problem or that mistake? So I'm going to take another flat toothpick. I'm just going to take some of that glue off. Sometimes science is messy. I can even use my finger, and all I want is just a little bit of glue. That's all I need. And now I can attach my toothpick. I have to let it dry, and then my barometer is ready to go. Take a look at the barometer I made before. When I made this barometer, my toothpick was lined up with that mark. Well, now my pointer has moved up. Well, what made it move? Well, all the air has added pressure, and it's pushing down on the balloon. And if you look carefully, the top of this balloon is actually flexed in, which makes my pointer move up. And if it's reversed, if the pressure is not as heavy or as high, my balloon will actually bulge out, which will make my pointer go down. Air pressure at work. So we've made a little working model so you can see how the barometer actually works in real time. This model works pretty simply. I have my little tiny barometer inside with a balloon stretched across the top. And this contraption is just a little plastic container that I stretched the balloon over. I left the bottom part of the balloon there so I can tug on it. And I can increase the pressure inside this jar by grabbing here and pushing down. And I can decrease the pressure by pulling up, kind of like our giant Earth. So here's how this works. I push in to increase the pressure, I pull up to decrease the pressure. Now let's zoom in and take a closer look at my barometer and see what it's doing while I'm pushing in and pulling up. So let's start playing around with the pressure. I'm going to push in, increase pressure, pull up, decrease the pressure. Push in, increase the pressure, pull up, decrease the pressure. In, up. High pressure, low pressure. High pressure, low pressure. High pressure, low pressure. So what's the big deal with all this air pressure? Well, scientists like to measure air pressure because it actually tells us what the weather's going to be like. If it's an area of high pressure, scientists have discovered that the weather typically is pretty nice. But if it's an area of low pressure, the weather can be pretty lousy, rainy, stormy. If you want to learn more about weather or weather instruments, check out our links in the video description. Weather is so cool. Sometimes it's warm. Thanks for watching.
Thanks for coming today, guys. You can pass off Science Unit 5, Lesson 3. Watching the recording and doing the questions is the exit ticket. So there's no exit ticket you need to fill out. Just watching the play pause it counts for that. Have a good day. Bye.